Assalamualaikum. My name is Nur Azrin Atika binti Zulkifli and my partner Nelina Fianti binti Sabudi. Today we will like to present about the lab 6, which is automated puncture and cooling system. Okay, for the sequence 1, the initial condition will display system on and press RB1 button. So here, trace A is for the output of 7 segment. Trace B is the input of switch. Trace C is the output for buzzer and relay 1. Trace D is the output for LED. And trace E is the output for relay 2. Okay, this is the coding for Here is the coding for sequence 1, which is we need to clear the display at LCD. And then here is the command if we want to display the system on. So system on will display at the row 1 of the LCD. So we use L1. And the press RB1 button will display on the second row in LCD, which is L2. And then for sequence 2, when we push RB1 switch, it will display system start. All LED 1 blink 4 times and buzzer on for 1 second. Okay, here is the coding for sequence 2. While we push RB1, so it will display system start. And then to make all LED 1 blink 4 times, we use for loop. Here is the when LED on, and here is the coding when LED off. And then to make the buzzer on for 1 second, here is the coding. RC1 equal to 1 to make the buzzer on, and change to 0, RC1 equal to 0 to make the buzzer off. So it will on for 1 second, so we need to put the delay 1000 here. Here is delay in milliseconds, so for 1 second we need to put 1000. And if the loop is bigger than 4, so the buzzer will off and the LED also will off too. And then for sequence 3, it will display press RB2 button. Here is the coding. Press RB2 button. And then for sequence 4, when we push RB2 button, the relay 1 on. At the same time, the relay 1 on, at the same time the relay 2 off, and buzzer will on. So here is the coding. And number 2, relay 1 off, relay 2 on, and the buzzer off. Then the 7 segment display 10 times counter of on or off above procedure. Okay, so here is the coding to display the 7 segment. And we use for loop for 10th time because the note say relay 1 and 2 on off synchronously for 10 times. So here the loop we use is 10, and then here is the coding. RC0 equal to 1 is when is the relay 1 on, and RE0 equal to 0, relay 2 off. For the relay 2 we use RE, and for the relay 1 we use RC. RC0, relay 2 RE0. So RC1 is the output for buzzer. So RC1 equal to 1 means the buzzer will on. And then we use the delay time 0.5 second. We use 500, that's mean 500 millisecond, that's mean is 0.5 second. And the other, when the relay 1 off, relay 2 off, and the buzzer off. So this is coding for number 2 here, and then this is coding for the number 1 here. So why we use the delay 0.5? So 0.5 plus 0.5, it will become 1. So the loop will continuously do the same thing. So the delay times 10, so it become 10 times. That's all from me. So I will pass to my partner to explain the rest of the coding.
So the next part is to display the cooling process. Okay, as you can see here, right after displaying cooling process, we are going to use potentiometer to on the fan at 3 volt and above, and display potentiometer value at LCD. So the voltage will be displayed at the LCD after 5 seconds, and the fan will stop if the potentiometer is more than 3 volt, but if the potentiometer is below than 3 volt, the fan will not be on. So as you can see here, at line 75, LCD string cooling process. Okay, this is the coding where we want to read the value at the potentiometer. ADC Amostra, and in the bracket 0 is because we want to use potentiometer 1. And if you want to use potentiometer 1, you need to put 0 here, but if you want to use potentiometer 2, you need just to replace it with number 1. 204 refers to the ADC count of the potentiometer. Okay, and so this is the coding to um, shift the input or string you want to display. And so I shift the string. I want to display 6 to the right. If you want to change it to 3, it also can. Okay, as for the LCD data string 3 and 4, it's already written at the eTOA. You can find it and at the source file here. Okay, then I put the delay for 1 second. So this is the coding where when voltage is more or equal than 3 volt, the fan will be on, and after 5 seconds the fan will be off. If the coding is below than 3 volt, the fan will not be on. Okay, and as you can see here, I put 0 here so that the character or char will be converted into integer. Okay, I will show you how the coding works. Press RB2 button. The fan will be on since the voltage is more than 3 volt. and after 5 seconds the fan will turn off. Okay, as for the next process is to display process done, press RB3. As you can see here, it already display process done, press RB3. And as for the next one, when RB3 is pushed, the LCD will display system shutdown. All LED one will blink 2 times, buzzer on for 2 seconds, and the system will be shut down. So as you can see here, this is the coding where we are going to push RB3. So display shutdown, I use for loop here to display an LED blink 2 times. So I set the for loop to 2 times. As you can see here, this is when the LED state is on, and this is when the LED state is off. I use delay to 50 millisecond. Okay, so after that, buzzer will be on for 2 seconds, and buzzer will be off right after that. Then an LCD will be cleared. That's mean that previously it displays system shutdown, right? So when we put this coding here, it will clear all of the string written at the LCD previously. So I also off all of the LED and the relay. As you can see here, when I push RB3, system shutdown. Okay, as you can see here, all relay will be turned off and LCD will be cleared, and it is supposed to off all of the LED, but since there is bug due to the coding, because we use RB2 as both of the input and output, as you can see here, so there will be bug here. We can just proceed it. Okay, that's all from us. Thank you.